Hi everyone! Today we're going to do a couple of different demonstrations, all having to do with the same overarching concept. I'm not going to tell you what the concept's name is here, but we will work together to develop a deeper understanding of what the concept entails. Tomorrow in class, we'll learn the concept's name and the specifics behind it. All the different demonstrations done here can be done using materials you most probably have at home. Once the video is over, rewatch it and do the demos with me. Let's work together to learn. Remember, take notes, answer the questions throughout the video, and write down any questions you may have after. Let's go. Here I have a Christmas card. If you want to try this experiment at home with me, you can use a piece of oak tag, cardstock, index card. You can even use a card if you have one at home. I wouldn't recommend using construction paper because that's not as thick and not as easy to stand on the table. So let's do this. So I'm going to blow directly inside the card, right through here, making sure none of the air that I'm blowing is going on the outside of the card. Let's try it. What happened? Why did my card not fly off of the table? Among other properties, stationary air exerts pressure. Flowing air exerts less pressure as compared to stationary air. The faster the flow, the lower the pressure it exerts. By blowing underneath the card, right through here, we actually created less pressure underneath the paper. So the pressure above the paper became larger than below the card. And this is why the card got pressed down to the table. In terms of moving molecules, we can see that by blowing underneath the card, the air molecules are pushed away from under the card. So when you're blowing under here, you're really pushing the air up like this. The air is being pushed towards the sides of the card. It's as if a partial vacuum is created at the spot where we're blowing. The air molecules that surround the card, those that are on the side as well as those above the airstream, are sucked toward the spot that we're blowing. In rushing to replace the molecules that were blown away, these air molecules are pushed on the upper side of the card, thus bending the card inward toward the table. I'm going to blow directly onto the flame with my straw, and that way you guys can see which way the flame moves. So it may be a little hard to see, but hopefully you can see that the flame isn't being directed towards me, it's being directed towards the opposite side of the room, the same direction that the air that I'm exerting is flowing. I'm going to now blow the air on both sides of the candle. We're going to see which way the flame moves when air is exerted near it. I'm going to start by blowing it on this side. Do you see how the flame is almost attracted to the straw? Weird, huh? Let's try this side. Same thing. The flame is being pushed almost toward the direction of the air. How is that possible? The air on the straw side of the flame is flowing as compared to the air on the other side of the flame, which is stationary. So as I'm blowing my air towards the candle, the air on the opposite side of the flame isn't moving. This exerts a lower pressure. For this reason, the flame bends towards the straw.